So in this problem, we need to resolve the given rational fraction into partial fraction. Let's begin. So here we have x over x plus 1. So this is the factor x plus 1, which is repeating 3 times. Multiply to another factor x minus 2, which is repeating 2 times. So we will have 5 partial fractions. So we'll suppose that, let's say that this rational fraction can be broken down into 5 partial fractions, with the first partial fraction being a over x plus 1. The second partial fraction is going to be b over x plus 1 whole squared. The third partial fraction will be c over x plus 1 whole cubed, followed by the fourth partial fraction, which will be d over x minus 2, and the final partial fraction will be e over x minus 2 whole squared. We're going to label this as equation number 1. Our goal will be to find the value of these constants a, b, c, d and e. Now we can easily find out the value of two constants first, c and e, by using a method known as the cover-up method. So using the cover-up method, the value of the constant c will be equals to, so we'll consider the original rational fraction, and here we're going to cover up x plus 1 whole cube. So this is going to leave us with x over x minus 2 whole squared. Now what we've done here, we have covered up x plus 1 whole cube. So if we equate this to 0, then we get the value of x, which will be equals to negative 1. All we have to do is substitute the value of x with negative 1, and c is going to give us a value negative 1 over 9. Similarly, we can also use the cover-up method to find out the value of e. For finding out e, all we have to do is consider the rational fraction, original rational fraction, and here we're going to cover up x minus 2 whole square. That means in the denominator, we're going to have x plus 1 whole cube. So what we have done here, we have covered up x minus 2 whole square. So if we suppose that x minus 2 whole square, that's equals to 0, then x will be equals to positive 2, and substituting this value in place of x, we're going to get e value, which will be equals to 2 over 27. Now, why can't we use the cover-up method to find out the other constant? Well, let's take for instance a. Let's say if we use the cover-up method, then what we can get, so a will be equals to x over, we can only cover up the factor x plus 1. That means one of the x plus 1 is going to stay. So x plus 1 times x minus 2, that should be the usual method, but when we use the cover-up method, we have to take x equals to negative 1, and that would mean that the denominator goes to 0, which is not allowed. So that's why we cannot find out the value of a, and similarly we cannot find out the value of b and d. So how do we find out the value of a, b and d? For that, what we'll do, we'll go back to equation number 1. We'll take equation number 1 and multiply both sides with the denominator x plus 1 whole cube times x minus 2 whole square, such that we get, on the left hand side we have x, on the right hand side we'll get x plus 1 whole squared multiplied to x minus 2 whole squared multiplied to 8. This is going to be the first term. The second term is going to be x plus 1 multiplied to x minus 2 whole squared times b. The third term is going to be x minus 2 whole squared times c. The fourth term is going to be x plus 1 whole cube multiplied to x minus 2 times d, and the final term is going to be x plus 1 whole cube multiplied to e. So let's label this as equation number 2. Now what we'll do, we can clearly observe here that this is an equation with an identity in x. So we're going to consider 3 values of x. For the first one, let's take x equals to 0. So we have to make sure whenever we're taking values of x, we don't consider the values which have already considered. That means we'll not consider negative 1 and positive 2. We will start with x equals to 0. Also, we will use the value for c we have obtained, that's negative 1 over 9, and the value of d, which is 2 over 27. So that means our equation 2, now that reduces to 2a plus 2b minus d equals to 5 over 27. So let's label this as equation number 3. Then we're going to consider another value of x. So we're going to consider x equals to 1, and c value negative 1 over 9 E value equals to 2 over 27. So this is not D, this is E. So solving, substituting these values in equation number 2 yields the equation 2a plus b minus 4d equals to 7 over 27. That's equation number 4. And finally, we're going to consider one more value of x. So we're going to consider, let's say, x equals to 3. So, and c value, that's negative 1 over 9, and our e value, that's 2 over 27. That gives us equation number 2 as 4a plus b plus 16d equals to negative 11 over 27. So this is equation number 5. Now, we can clearly observe here that equations 3, 4 and 5, these are simultaneous linear equations with variable a, b and d. So I'm leaving this as an exercise for you to find out the value of a, b and d. I'm writing out the result. So a comes out to be 1 over 27. Then b comes out to be 1 over 27 as well. And then we have d. So d comes out to be negative 1 over 27. So we have a, b and d, and we have already found out the value of c, which is 1 over 9, and e value, which is 2 over c is negative 1 over 9 and e is 2 over 27. We can substitute all these 5 constant values back into our equation number 1, and that will give us the final result. So let's do that. Thus, our final rational fraction, x over x plus 1 whole cube multiplied to x minus 2 whole square. So this can be split into 5 rational fractions, with the first partial fraction will be 1 over 27 times x plus 1. The b value is also 1 over 27, so we have 1 over 27 multiplied to x plus 1 squared. Then c value, which is negative 1 over 27, no, that's negative 1 over 9, so we have negative 1 over 9 times x plus 1 whole cube, and our d value will be negative 1 over 27 times x minus 2 plus e, which is 2 over 27 times x minus 2 squared. So this is going to be the final result.